is a circle that has its center at the origin at 0, 0. And it's always going to be written with the equation x squared plus y squared equals 1. And that means then it has a radius of 1. If we want to move it around, to move it horizontally, we're going to add an h number in there. And to move it vertically, we're going to add a k number with our y, just like we have been with all of our other functions. And then finally, we're going to have our radius squared. So here we graphed x squared plus y squared equals 1. We can graph that on our calculator in a minute, but if we were to graph that by hand, essentially what they're saying is we're going to start with 0, 0 as our center, because there's no numbers in here, so here's my center. And then if my radius is 1, what's radius? Do you remember from geometry? Halfway across the circle, right? Half the diameter. So if this was 1, 1, 1, 1-ish. Again, remember this is an art class, so we're going to be close. We'd go out from our center point, 1 in each direction. And when we connected those dots, and we could fill them in, because one this way, and one that way, and one this way, and one this way, one this way, etc., we would get our circle. If we wanted to look at a circle that had a radius other than 1, or a center that was not 0, 0, we would use this new equation up here. So let's just 1 second look at a different equation. Let's look at x minus 2 squared plus y minus 1 squared equals 25. Now, if we look at our graph, this number is going to move it to the left or the right, because it's with my x. The number with my y is going to move it up and down. And 25 is the same as my radius squared. So if my radius squared is 25, what's my radius? 5. So we know our radius equals 5, okay? And this is essentially your center of your circle. Instead of the center being 0, 0 like it was up here, now my center moves over, and now my center is going to be 2, 1. And I know for sure on Thursday there's going to be a problem like that on your test. And it's going to say, what's the center of this circle? The center of this circle is what? 2, 1. And if I wrote it as an ordered pair, it'd be 2, 1. If I wanted then to graph that by hand without using my calculator, because you're going to see in a minute my calculator is kind of a pain, I would just make my axis. I find my new center, 2, 1. So over 2, up 1. And then from that point I need to go 5 in each direction, because I go out to my radius. So I'd be 1, 2, 3, 4, 5, make a dot. 1, 2, 3, 4, 5, make a dot. 1, 2, 3, 4, 5, make a dot. Yeah, close. 1, 2, 3, 4, 5, make a dot. And then I would just connect all my dots until I was circle-ish. And because I can't draw, my whole life I've just labeled my points. Then everyone knows what they are. 2, 1. Radius equals 5. That way, even if it looks terrible, whoever's grading it knows exactly what it says. What if, instead, we said we were talking about a circle, and you'll know it's a circle because it's going to be an x squared, y squared. X minus 1 squared plus y plus 1 squared equals 16. First of all, what's the radius of that circle? What's the radius? 4. Is that right? Mm-hmm. Because it's the square root of 16, so the radius is 4. And what's the center of my circle? Yep. 1, -1. Why? Why isn't it -1, 1? Because it's inside the parentheses. And everything we've done inside the parentheses has been what? Has it been the same as what you thought, or has it been the opposite of what you thought? The opposite. So because it's inside the parentheses, essentially we think change the sign. So this is going to become positive, this is going to become negative. It's really because the original equation up here had negative signs here and here. So once you put in a positive number, it makes it negative, and when you put in a negative number, it makes it positive. So 2 negatives would switch this. If I put a -1 in, that's going to swap the sign. But it's a lot easier for most of us just to remember to do the opposite of what we thought. Since it looks like it's positive, we switch the sign and make it negative. Since it looks like it's negative, we switch the sign and make it positive. Questions about that? So this is my center. This is my radius. Center numbers are opposite of what I think. The radius is just the square root of what I think. It's okay? Now, I am going to promise you that it is much easier for me to draw this now. So I would go, okay, well I need to go 1 to the right and then down 1. And then I'm going to go 4 in each direction. Say it's about there and there and there and there. And I'm going to connect my points to make it circle-y. And then because I can't draw, I'm just going to say this is 1, -1 with a radius of 4. And I'm done. If you wanted to do it on your calculator instead, the first thing you have to do is put it in y equals form, because we can't graph anything with an x squared and a y squared. So to put it in y equals form, I would subtract the x squared on both sides. That would leave me y squared equals 1 minus x, because this guy canceled out. Then I'm going to have to do what if I have a squared here and I want to get rid of it? What? Oh my gosh, we're so tired this one. Take the square root of both sides. When I take the square root of this, I get y. When I take the square root of this, I have a plus the square root of 1 minus x squared and a minus the square root of 1 minus x squared. And I can graph that on my calculator to get the full circle because I have the top half and the bottom half. So take a minute and snag your calculators out if you would. And they have to go in 2 separate lines on your equation. So you're going to have your first line is going to be second x squared, you get your square root. So the square root of, and remember how important I told you it was before that we kept our parentheses? 1 minus x squared, end my parentheses. Bless you. And my second line is going to be negative, remember negative, not the minus sign. Second x squared of 1 minus x squared, end parentheses. So I have the top half of my circle and I have the bottom half of my circle. And if you zoom 6, it might look a little footballish instead of completely circly.
I have a question.
But it'll be close. Yes.
Is the square root supposed to be over the entire thing?
Yes.
So we
that's
can
why
just type it in how...
you have to end your parentheses at the very end.
Yeah, but like ours, you know how it's like different? Can we just do it?
Yes.
Like this? Okay.
But not for this one, you can, but there might be somewhere we have to add a number at the end.
Yeah.
And you can see, even though it looks a little football-y, it goes up 1, over 1, down 1, over 1 to the left. So my radius is 1, just like it was in my original equation. And my center is at 0, 0. If we move that center around, if we change that radius at all, that's going to change our equations and then change our pictures. We're also going to have some of them that aren't quite circles, but rather are ellipses. An ellipse is a circle that's been stretched or shrunk in one direction more than another. So same idea if you haven't seen an ellipse before. My circles are almost all ellipses because none of them are actually perfectly round. But it's going to either be long this way or long vertically. And to do that, to make it long in one direction or the other, they're going to take that exact same formula they had for the circle, the x squared plus y squared equals 1, and we're going to add a number, a stretch number, on the bottom of the x and the y. It could be a 1, it could be anything. And that's just going to tell us how far we stretch in each direction. The only number that stays the same now, and it's different than our other equations, where instead of a radius number being here, like the 1, that's always going to be 1 for ellipses. It's never going to be anything besides 1. Always, always 1. And now we're going to get our radius or stretch information from these two numbers on the bottoms. If those numbers are the same, if it's both 4, 4, it's going to go back to being a circle. So if those numbers are not the same, then we're set. So an ellipse has got two different numbers on the bottom, like a 4 and a 3. Those numbers are going to tell you the horizontal stretch is always going to be the one under the x. Remember, everything horizontally is done with our x, because our x-axis is the long one. This is the horizontal one. And then everything that's going up and down is always going to be under our y, because that's our vertical axis. So in this instance, it's still easier to graph it by hand than it is on our calculator. If there's not a number up here with the x or the y, then our center is still 0, 0. And we'll look at one that has a center that's something other than 0, 0 in a minute. But because there's no number up here next to my x or next to my y, I'm still going to be centered at 0, 0. And now the number under my x is going to tell me how far I go in the x direction. So on my x-axis, from my center point, I'm going to go 4 in each direction. Okay? And on my y-axis, I'm going to go 3 in each direction, because the number under my y is 3. And if I connect then my endpoints in a nice little curve-ish sort of a feature, then we end up with an ellipse, who has a horizontal stretch of 4 and a vertical stretch of 3, and is centered at the origin, or 0, 0. So under my x are my vertical and horizontal stretch. Horizontal under the x, vertical under the y. Numbers on the top are still going to give me just that center point. If we have the same number on the bottom, then it's a circle, because you're going up 2, over 2, 2 in each direction makes it a circle. So if we wanted to make that something centered other than 0, 0, we add an h value in here to move it to the left and the right from the center, and our k value next to the y, just like we did for our circles, to move it up and down. And so essentially, if we wanted to graph that without having to use our calculator, we'd still go, okay, draw myself some axes. So I'm going to draw an axis somewhere here, let's see. I have my Y, and I have my X, good. And now, instead of my center being at 0, 0, my center is at what? 3, 1. And both of them are positive, it's the opposite sign of what I think. So I'm going to go over 3, 1, 2, 3, and up 1, and make my center point, so I know where I'm starting, okay? Then, because it's an ellipse, it's got these great numbers on the bottom here. So on my x-axis, from my center point, I'm going to go 4 to the left and 4 to the right. So I have 1, 2, 3, 4 to the left. 1, 2, 3, 4 to the right. And then on my y-axis, I'm going to go up and down 3. So I have 1, 2, 3. Look, I can't draw, so clearly those aren't straight, but we're good enough. 1, 2, 3. And then I'm just going to connect my points. Is it beautiful? No. Those of you who are artistic will have much more beautiful, or at least symmetric looking ellipses. But I might put in then that my center was 3, 1, so I can remember. And I could put like, make a little indicator like this is 3 and this is 4, for those of you who are hoping that you can draw just as beautifully as me. If you were to try to put that in the calculator, and some of our problems from Friday were leading up to this, so if you haven't gotten to them yet, this will be an excellent opportunity. In order for us to put that in the calculator, and the reason I'm saying it was easier to do it by hand, is we have to get this y all by itself to be able to put that in the calculator. That is a lot of effort. Significantly more effort than me going 3, 1 over 4, up 3. Done. If I were really bored, I would subtract this from both sides. So on this side I have y minus 1 over 3 squared equals 1 minus x minus 3 over 4 squared. Then I would take the square root of both sides. So the square root of this is perfect because that cancels out. But it's the square root of this whole thing. So that doesn't change over there. And I would end up with y minus 1 over 3 equals plus or minus the square root of 1 minus x minus 3 over 4 squared. Then I'd have to times by 3 on both sides to cancel that out. So I'd have y minus 1 equals plus or minus, 3 times 1 minus all that stuff in parentheses. And then I'd add 1 on both sides. And I'd finally have y by itself. So I'd have y equals plus and minus, so I'd have the top and the bottom, 3 times the square root of 1 minus all that stuff in parentheses squared, and my square root sign, plus 1, and then I'd have negative 3 and all that stuff.
A lot of work.
It seems like a lot of work compared to 3, 1, 4, 4, 3, 3. Oh, look at my picture. It's beautiful. I know. I didn't even get close to my 3 on the bottom, but I knew he was too far off, so. Okay, so we are going to try a few today and finish up our assignment from Friday. So we're going to look at a few circles. I'm going to go ahead and put the assignment up on the board in just a minute because I want to change it a little bit compared to what it was on the original lesson plan. So you can go ahead and get Friday's work out. If you did not finish Friday's work, I would like you to finish that and put it in the tray for us. I think one person had it done and turned in on Friday, maybe 2. Not very many of you though, so you should have an assignment for Friday to do. Okay? And then we'll add our new assignment for today and we shall be good.
Why?
Yeah, see.
That happens to me a lot though.
I think you're done now. I don't think we're taking it.